Good morning, children. So, we are doing chapter 3, current electricity. Today, we are going to start with the topic drift velocity. So, children, yesterday we saw the condition inside the conductor in absence of electric field. We saw that in absence of electric field, that is this condition. In absence of electric field, the free electrons, they are in random motion. The free electrons are in random motion. They move due to the energy from the surrounding. They take energy from the surrounding. Surrounding, mute yourself, children. They take the energy from the surrounding temperature, right? And they are moving with a random velocity. They move, the electron move randomly, right, child? Now what happens inside this, as you can see the electrons, suppose this is the magnified view I am showing you, right? So these are your electrons inside these are your free electrons inside your conductor. Now, by taking the energy from the surrounding, that is the thermal energy, these electrons are going to perform a random motion, right? And suppose the velocity of this electron is u1, this electron is moving downwards, this electron is moving towards right, this electron is moving towards left, this is moving at some angle over here, this is moving like this, right? This is moving like this and this is moving like this. So what happens, as the electrons are in random motion, the number of electrons moving in one direction is equal to the number of electrons moving in opposite direction. As you can see here, this electron, it is moving in upward direction, and this electron is moving in downward direction. So the net of these two electrons, will be 0. So the net velocity, the average velocity of all the electrons which are in random motion comes out to be 0. उसकी जो average velocity है बेटा वो 0 हो जाती है. So you are not getting any current when a conductor is lying without any बैटरी. कंडक्टर के साथ बैटरी कनेक्टेड नहीं है तो इसीलिए हमें तब करंट नहीं मिलता है, बिकॉज देयर इज नो नेट फ्लो ऑफ इलेक्ट्रॉन्स इन वन डायरेक्शन. एक ऊपर जा रहा है, एक नीचे जा रहा है, एक इलेक्ट्रॉन राइट जा रहा है, एक इलेक्ट्रॉन लेफ्ट जा रहा है. सो द नेट एवरेज वेलोसिटी बिकम्स 0 and there is no net flow of electrons in one direction. और करंट तो तभी प्रोड्यूस होता है when the current is moving in one direction, right? So that is the case for absence of electric field. So let's see, the expression is over here. Free electrons, they are in random motion due to thermal energy, right? But their average velocity, suppose u1 is the velocity of electron, right? This is random velocity. u2 is the random velocity of electron number 2. u3 is the average velocity of random velocity of electron number 3, right? Similarly u4 ये भी एक velocity है, right? This is also velocity of electron number 4. Similarly un is the velocity of electron number n, but they are in random motion, right? So their average, now how we will do average? Average is by adding u1 plus u2 plus u3 plus ... un upon the number of electrons, so upon n. equals to 0. Why it is equals to 0? Because we are not getting the velocity or the movement of electrons in one direction. They all are moving randomly and they are cancelling out each other, right? So no current as the electrons are not moving in a particular direction, right? Now what we are doing is, now we are connecting a battery. Now we are connecting a battery. Fine, let us connect a battery now, right? So as you can see here, we have connected a battery having voltage V. We have connected a battery having voltage V. So this battery which is connected across the conductor, ये आपकी वायर है, वायर इतनी मोटी नहीं है, zoom किया हुआ है, right? आप निक्रोम की वायर ले लो या कुछ भी ले लो, right? So this conductor is having length L and the potential that we have applied is V. Now, because of the application of the potential, it produces electric field. And we know the direction of electric field is from positive to negative. So, this is your direction of electric. This is your direction of electric field from positive to negative. So, what will happen inside the conductor? We know inside the conductor there are 10 to the power 28 free electrons. कितने सारे free electrons हैं. So what will happen to those electron? Electron is over here and the positive side is over here. So what will happen? But obvious, the electron will experience a force in the direction opposite to electric field. Electric field is in this direction, right? From positive to negative, right? From positive to negative. And the electrons which are inside the conductor, free electrons, they will experience a force towards the positive terminal because negative electrons होते हैं positive की तरफ attract होंगे, right? So उसके ऊपर एक force लगेगा. That force we know is equal to F equals to minus E into E. This is electric field. This is the charge of the electron, right? Minus sign shows that the force that is acting on the electron, ये जो electron पे force लग रहा है, वो किस direction में? इस direction में. And the electric field that is in opposite direction. So as the electric field and the force, they are in opposite direction. So we are having a minus sign over here. So F equals to minus E into capital E. That is the force that the free electron will experience inside the conductor on connecting a battery of voltage V, right? Now, उसके अंदर इलेक्ट्रिक फील्ड प्रोड्यूस होगी, ठीक है, हमें पता है यहाँ पे भाई इलेक्ट्रिक फील्ड प्रोड्यूस हो रही है. अब ये इलेक्ट्रिक फील्ड कितनी है? दिस आल्सो वी हैव डन इन द प्रीवियस चैप्टर. E equals to V upon D. That is E equals to V by L, right? Now what we will do, this value of E we will substitute in this. So let us see what will happen. Now we know F force कितना है? Minus E, right? From Newton's second law we know F equals to ma. From Newton's second law we know F equals to ma. So if we equate these two equations, हमें मिलेगा ma equals to minus E capital E. If I make A subject of formula, A is acceleration. A is acceleration. Then we will get minus E capital E upon M. So because of the force applied by the electric field, the electrons will get accelerated. Accelerated मतलब उसकी velocity increase हो जाएगी electrons की. और वो किस तरफ move करेंगे बेटा? Towards the positive side, opposite to the electric field, right? So because of this force, which force beta? This force, that is minus E capital E. Because of this force, ये force किसकी वजह से लग रहा है? Because of the electric field. तो electric field जो ये force लगा रही है, इलेक्ट्रॉन के ऊपर इस फोर्स की वजह से इलेक्ट्रॉन्स की जो वेलोसिटी है दैट विल गेट इंक्रीज, वो चेंज हो जाएगी उसकी वेलोसिटी, दैट विल get the electrons will get accelerated means change in velocity हो जाएगी. How much? A equals to minus E capital E upon M. So electrons जो है they will get accelerated and they will gain a velocity. Okay, electrons के पास एक नई velocity आ गई है. ठीक है बेटा. अब electrons के पास velocity आ गई है, fine. But velocity बेटा वो कब तक रहेगी? That velocity will remain till that velocity will remain till the electron experiences the next collision. आपको पता है the electrons are continuously in collision. The electrons inside the conductor over here, even over here, the electrons, they are continuously moving and they are in continuous collision with the positive ions as well as with the electrons themselves. So अंदर वो जो है वो continuous collision तो चल ही रहा है, हमने बाहर से electric field apply की है. So what happens? Because of that electric field, a force is produced that is minus E capital E, and this force, it accelerates the electron and it gives velocity to the electron. इलेक्ट्रॉन के पास एक और एडिशनल वेलोसिटी आ गई, ज्यादा हो गई अब उसकी वेलोसिटी. बट ये जो वेलोसिटी है ना, ये जो खुशी है, ये बहुत शॉर्ट टर्म खुशी है. अभी ये वेलोसिटी इसकी खत्म हो जाएगी. सो इसकी वेलोसिटी बेटा कब खत्म हो जाएगी? जब ये नेक्स्ट कोलिजन करेगा, मतलब जब ये नेक्स्ट टकरा जाएगा तो उसकी जो वेलोसिटी है वो खत्म हो जाएगी. कौन सी वेलोसिटी? द वेलोसिटी which it gained due to the acceleration by the force F equals to minus E capital E. वो फोर्स लगने की वजह से वो एक्सेलरेट हुआ, उसे एक वेलोसिटी मिली, but वो वेलोसिटी will remain for a very short time. So as you can see over here, the picture over here, right? So what happens? ये जो इलेक्ट्रॉन है यहाँ पे आपको रेड, you can see the electron I've shown with the red, right? This is an electron. So this electron this electron has got accelerated and it has gained velocity. ये वेलोसिटी कब खत्म हो जाएगी? जब ये इलेक्ट्रॉन इस पॉजिटिव आयन से टकरा जाएगा, उसकी खुशी, उसकी वेलोसिटी खत्म, ओवर एंड आउट. एंड आफ्टर द कोलिजन के बाद it will start again with a fresh thermal velocity के साथ स्टार्ट होगा. फिर वापस से इलेक्ट्रिक फील्ड अपना फोर्स लगाएगी, F equals to minus E capital E. उस फोर्स की वजह से वापस वो इलेक्ट्रॉन एक्सेलरेट हो जाएगा, वापस से उसे वेलोसिटी मिल जाएगी और वापस से वो खुशी थोड़े टाइम की है. वापस से नेक्स्ट कोलिजन, velocity lost and it will start with a fresh thermal velocity. So वो जो शॉर्ट टाइम जिसमें इलेक्ट्रॉन को खुशी मिल रही है, जिसमें इलेक्ट्रॉन एक्सेलरेट हो रहा है, जिसमें इलेक्ट्रॉन को एडिशनल वेलोसिटी मिल रही है, वो जो छोटा सा टाइम पीरियड है उसे बोलते हैं बेटा रिलैक्सेशन टाइम, राइट? सो वेरी इंपॉर्टेंट, दैट इज द शॉर्ट टाइम फॉर व्हिच इलेक्ट्रॉन एक्सेलरेट्स बिफोर इट कोलाइड्स, है ना? कोलिजन के बाद तो खत्म ही हो जाएगा, उससे पहले उसके बाद वो एक्सेलरेटेड रहता है, तो वो जो छोटा सा टाइम है दैट इज कॉल्ड द रिलैक्सेशन टाइम, एंड द रिलैक्सेशन टाइम इज डिनोटेड बाय tau. The relaxation time is denoted by tau, right? Here also you can see we are going to use this time everywhere, because here we are going to talk about time that is not simple time, but over here relaxation time. So here instead of t you will see tau everywhere, right? So when we are applying electric field, जब हम electric field लगा रहे हैं तो इलेक्ट्रॉन के पास ओरिजिनल इनिशियल वेलोसिटी कौन सी है? सपोज आई एम टॉकिंग अबाउट इलेक्ट्रॉन नंबर 1, सो इनिशियल उसकी वेलोसिटी है u1. u1 कौन सी थी? दैट वाज थर्मल वेलोसिटी, राइट? इस सराउंडिंग का टेम्परेचर लिया और रैंडम मोशन कर रहे थे, दैट वाज u1. बट ऑन एप्लीकेशन ऑफ इलेक्ट्रिक फील्ड एक्सेलरेट हो गया, उसको और वेलोसिटी मिल गई. So we know the formula for velocity. As we know, acceleration is what? Acceleration is change in velocity upon time. Can I write like this? So if I make v subject of formula, v equals to at. तो यहाँ पे a तो रहेगा but t की जगह आ जाएगा tau. So this is the velocity which the electron will gain. इलेक्ट्रॉन एक्सेलरेट हो रहा है तो ये वेलोसिटी उसको और मिलेगी, एडिशनल हो जाएगी. तो अब इलेक्ट्रॉन नंबर 1 की वेलोसिटी क्या हो जाएगी? u1 प्लस a tau 1, क्योंकि हम इलेक्ट्रॉन नंबर 1 की बात कर रहे हैं, राइट? नाउ सिमिलरली फॉर इलेक्ट्रॉन नंबर 2, फॉर इलेक्ट्रॉन एंड आई विल नेम इट एज v1. v1 कौन सी वेलोसिटी है? v1 इज द फाइनल वेलोसिटी, राइट? बिफोर कोलिजन, कोलिजन के बाद तो बेचारी लॉस्ट हो जाएगी, राइट? And if I talk about electron number 2, electron 2 initial velocity is u2, that is thermal energy, and due to electric field it gets accelerated, and this is the additional velocity which will be added, right? Similarly vn लिखे हम तो n electrons है, n electrons, that is 10 to the power 28 electrons per meter cube. एक मीटर क्यूब के वॉल्यूम में 10 to the power 28 इलेक्ट्रॉन्स. तो ये Vn, that is Un plus a tau n. So I hope this is clear. This is the total velocity. Now the term drift velocity, right child? Drift velocity. So as you know children, that before the connection of the battery, the electrons were doing very casual movement, random कर रहा था, एक ऊपर एक नीचे, एक लेफ्ट एक राइट, फाइन. अब वो वाला मोशन तो वो कर ही रहे हैं, but along with that motion, as we have connected a battery over here, right? So because of the connections, sorry, let me remove it. So because of the connection of the battery, this side becomes positive, this side becomes negative. तो ये जो बेचारा इलेक्ट्रॉन है, ये random motion तो कर ही जा रहा है, but along with the random motion, it is moving in the forward direction also, because it is getting attracted towards the positive terminal. So random motion चल रहा है, so it is moving up and down, zigzag everywhere. But along with that, it is proceeding towards the positive terminal of your battery, right? So the velocity with which your electron is drifted, is dragged, electron move, electron को खींचा जा रहा है. तो जब खींच रहे हैं, फोर्स अप्लाई हो रहा है, तो उसमें एक वेलोसिटी वो गेन करेगा. That velocity is known as your drift velocity. So the definition of drift velocity is the average velocity, उसकी जितनी भी average velocity है, that the electron will gain, जो कि free electron को मिल रही है, right? और वो कब मिल रही है? जब आपने external field apply किया. But उसकी direction क्या है? उसकी direction है, the electric field is in this direction, the electrons are moving in this direction. So this is your direction of drift velocity, that is opposite to the direction of external electric field. So the average velocity, जो velocity electron gain करने वाला है, जो उसे मिल रही है, right? So the average velocity gained by an free electron in the direction opposite to that of electric field, that is your drift velocity. So drift velocity is average velocity. So velocity v1 ये है, v2 ये है, vn ये है. इसका क्या करना है? हमें average find करना है. So drift velocity को symbol होता है vd. You can see over here. The symbol of drift velocity is Vd. So Vd equals to average of the velocities. The average, how we will find? V1 plus V2 plus V3 plus dot 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 Vn upon n number of electrons. So upon n, right? Now what we are doing? V1 value we are substituting from here in this. So we will get this. Similarly, value of V2 will substitute, we are getting this. Similarly, the value of Vn we are substituting, we will get this upon n, right? Now what we are doing? We are separating the terms. All u terms, u1 plus, u2 plus, un, separate, plus all acceleration terms, a tau 1 plus a tau 2 plus dot 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 a tau n upon n, right? Now, if you see this term carefully, what is this? This is your average velocity due to thermal energy. See, I'll show you. Here it is. ये देखो. This is your average velocity due to thermal energy, right? When the electrons were in random motion. So ये तो भाई zero होता है, right? So this is zero. Okay. If this is 0, we will substitute instead of this 0. Now what we are left with? We are left with this term now. From this we are taking a common, and inside we will get tau 1 plus tau 2 plus dot 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 tau n upon n. Right? Tau is what? Relaxation time. Right? और ये उसका एवरेज का फॉर्मूला हो गया ना. देखो एवरेज में क्या करते हैं? टोटल, that is addition of all upon number of them. So this is your average relaxation time which you are denoting by tau. So a tau. So Vd equals to a tau. But a हमें पता है. We know the value of a that we had calculated on the previous page. That is minus E capital E upon m. I'll show you here with it. Here you can see acceleration is minus E capital E upon m. Right? So this is your formula for your drift velocity, that is a tau, where a is the acceleration and tau is the average relaxation time. Putting the value of a as minus E into capital E upon m into tau. Here the negative sign shows that the drift velocity, that is the velocity with which the electrons are drifted, that is opposite to the electric field. That is opposite to the electric field. Right, children? So this is your drift velocity, and here you can see the definitions of the two, drift velocity and the relaxation time. Right? Drift velocity and the relaxation time definitions are up here. Quickly we will read them once. Right? Drift velocity कौन सी velocity होती है? That is average velocity, जो कि इलेक्ट्रॉन गेन करता है. ठीक है? और कौन सी डायरेक्शन में? ऑपोजिट टू इलेक्ट्रिक फील्ड, है ना? क्योंकि इलेक्ट्रॉन्स तो ऑपोजिट टू इलेक्ट्रिक फील्ड ही मूव कर रहे हैं, क्योंकि इलेक्ट्रिक फील्ड हमेशा पॉजिटिव से नेगेटिव होते हैं, और इलेक्ट्रॉन जो है वो तो पॉजिटिव की तरफ जाएंगे. So the average velocity gained by free electrons in direction opposite to external electric field is called your drift velocity, that is Vd. Right, beta? Next is you can see relaxation time. So relaxation time is the average time between the two successive collision. दो collision के बीच का time, उसे बोलते हैं हम relaxation time, है ना बेटा? दो collision के बीच का time, that is the relaxation time, and it is of the order of 10 to the power minus 14 seconds. बहुत कम टाइम है, 10 to the power minus 14 seconds. इस ऑर्डर का आता है बेटा रिलैक्सेशन टाइम, एंड रिलैक्सेशन टाइम वी नो दैट इज डिनोटेड बाय टाउ, and your tau is your average relaxation time, that is t tau 1 plus tau 2 plus dot 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 tau n upon n. Right?